Hi, good morning everyone. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. Today we are going to discuss about the star delta conversion under the unit of network theorem and source transformation. Let's get into the topic. Star delta conversion, why it is required? Here in our first unit or the second unit, we used to find the equivalent resistance or equivalent by means of series and parallel method. That is, if it is series, if two resistance are series, we add these two resistance that is named as R1 and R2. So R1 plus R2. If it is parallel, we use the formula R1 R2 by R1 plus R2. So this is the method we use to find the R equivalent value. But this series and parallel method will not be applicable for all the circuits. If the circuit is more complex, then using the series parallel method will be very difficult. So to alternate, for the alternative option, we have the star delta conversion. That means that if the network is looks like the star, that means star means we have one junction point. In the junction point, three resistors joined together. That point that is called a star. So if it looks like this can be converted into delta. So delta means we have delta symbol we everyone knows. So like that we can convert, and also delta to star also we can able to convert. So by using the star delta conversion or delta to star conversion, we can simplify any complex network resistance. In any complex network, we can find out the equivalent resistance value. So that's the purpose of the star delta conversion method. So the star and delta formation of the resistance is a standard three-phase circuit or network of a resistance connected in the same way as their name suggests. Star formation of resistance looks like this below. So A, B, C, three terminals, and here it's a junction point, and here it is named as R1, R2, and R3. So delta formation of resistance look like this. So R here A, B, C is there. So in between A and B, the resistance is named as R12. In between B and C, the resistance is named as R23. And in between AC, the resistance is named as R13. So, delta to star conversion means, so this is the thing. So, if the network which consists of this formation of network, then we can easily convert into this star type. So, to convert the delta to star, we are using some formulas to convert delta to star and as well as star to delta. Here are the formula for transformation. Here R12. So R12 we know that is mentioned in this previous slide. So that means here we have to apply R1 into R2 by R1 plus R2 plus R3. Note that the above formula cyclic in nature, hence it works the same for R23 and R31. So the proof there is shows that R1 equal to R1 plus by R1 into R2 by R1 plus R2 plus R3. So let us consider the resistance from A to C, that is A to RAC, that is left R2 in parallel with R1 plus R3. RAC left R2 into R1 plus R3 by R2 plus R1 plus R3. So RAC right R12 plus R23. So equating the two, so here R2 into R1 plus R3 by R2 plus R1 plus R3, which is equal to R12 plus R23. Similarly, R3 into R2 plus R1 by R3 plus R2 plus R1, which is equal to R23 plus R31. So similarly for this term also. So finally, when you see R12, which is equal to R1 R2 by R1 plus R2 plus R3. So here, similar like delta to star, here we have a star to delta. So star to delta also we have some set of formulas. So the formula is here, we can go for this one. So R12 which is equal to R1 plus R2 plus R1 R2 by R3. So note that the above formula is cyclic in nature, hence it works for the same for R23 and R31. So the proof of this formula is given here. So the result of the the above proof become R3 equal to R23 into R13 by R1 plus R13 plus R12. And similarly, the other terms also we can derive the equation. Thank you.